Focus area of plus 1 chemistry, chapter 3, classification of elements. And periodicity in properties. And periodicity in properties. Periodicity in properties. This is the third chapter in first year chemistry. Okay, first question. Questions based on focus area. First question, modern periodic law. Modern periodic law. This law was introduced by Moseley. Okay, the law states that physical and chemical properties of elements are periodic functions of their atomic number. Physical and chemical properties of elements are periodic functions of their atomic number. That is, properties, physical and chemical properties changes with change in atomic number. This is modern periodic law, and this law was introduced by Moseley. This is the first question. Then second question, write about long form of periodic table. Write about long form of periodic table, or write about modern periodic table. It is based on atomic number. It is based on atomic number. Here, elements are arranged in the increasing order of atomic number. Next point, here horizontal rows and vertical columns are present. Horizontal rows are called periods. Horizontal rows are called periods. Vertical columns are called groups. Vertical columns are called groups. There are 7 periods and 18 groups. There are 7 periods and 18 groups in this modern periodic table. Modern periodic table. It is based on atomic number. Here, elements are arranged in the increasing order of atomic number. Here, horizontal rows and vertical columns are present. Horizontal rows are called periods and vertical columns are called groups. There are 7 periods and 18 groups in modern periodic table. Okay. First period contains two elements. First period, two elements. First period. Second and third periods contain 8 elements each. 8 elements each. Fourth and fifth periods contain 18 elements each. Sixth period contain 32 elements. Seventh period incomplete period. Okay, these are periods in modern periodic table. Next question. What are the four blocks of elements? What are the four blocks of elements? Okay. Elements are classified into four blocks. First, S block elements. S block elements. First one, S block elements. Elements in which last electrons enter in S subshell. Last electron enter in S subshell. Last electron enter in S subshell. Last electron enter in S subshell. They are group first and group second elements. S block elements are group first and second elements. Their general electronic configuration is NS1 to 2. That is NS1 or NS2. This is the general electronic configuration of S block elements. Second, P block elements. Elements in which last electrons enter in P subshell. Last electrons enter in P subshell. They are group 13 to 18. Group 13 to 18. Their general electronic configuration is NS2 NP1 to 6. Third, D block elements. Elements in which last electrons enter in penultimate D subshell. Penultimate D subshell are called D block elements. They are group 3 to 12. Their general electronic configuration is NS2 N-1 D 1 to 10. Last electrons enter in penultimate D subshell. They constitute group 3 to 12. Their general electronic configuration is NS2 N-1 D 1 to 10. Then fourth one, F block elements. F block elements. Here, last electrons enter in anti-penultimate F subshell. Last electrons enter in anti-penultimate F subshell. They are lanthanoids and actinoids. They are lanthanoids and actinoids. Lanthanoids and actinoids. Their general electronic configuration is NS2 N-1D 0 to 1 N-2 F 1 to 14. General electronic configuration is NS2 n minus 1 d 0 to 1, n minus 2f 1 to 14. These are the four blocks of elements: S block, P block, D block and F block elements. Next question: representative elements. Representative elements. S and P block elements are collectively called representative elements. S and P block elements are collectively called representative elements. S and P block elements are collectively called representative elements. Next question: noble gases or inert gases. Inert gases. 18th group elements are called noble gases. 18th group elements are called noble gases. They are helium, neon, argon, krypton, xenon and radon. Their valence shell is completely filled. Valence shell is completely filled. Therefore, they are not taking part in general chemical reactions. So, they are called inert gases. Their valence shell is completely filled. Therefore, they are not taking part in general chemical reactions. Next question: transition metals. Transition metals or transition elements. D block elements are otherwise called transition elements. They are metals. They are good conductors of heat and electricity. They are malleable and ductile. Malleable and ductile. They show variable oxidation state. Variable oxidation state. They produce colored compounds. Colored compounds. They act as catalyst. They act as catalyst. Okay. These are the properties of transition elements. D block elements are called transition elements. They are metals. They are good conductors of heat and electricity. They are malleable and ductile. They show variable oxidation state. They produce colored compounds. They act as catalyst. Next question: ionization enthalpy. Ionization enthalpy or ionization potential. Amount of energy required to remove most loosely bound electron. Most loosely bound electron from an isolated gaseous atom. Isolated gaseous atom. It is called ionization enthalpy. Amount of energy which is required to remove most loosely bound electron far from the nucleus. That is less attractive force between that electron and the nucleus. That is most loosely bound electron from an isolated gaseous atom. That atom is isolated and it is in gaseous state. Okay. That atom is isolated. That is single atom. It does not combine with any other atom. That atom is in gaseous state, and amount of energy required to remove most loosely bound electron from that isolated gaseous atom. It is called ionization enthalpy or ionization potential. Next question: factors affecting ionization enthalpy. Factors affecting ionization enthalpy. First one: size of atom. Size of atom. Second one: nuclear charge. Nuclear charge. Third one: half-filled and completely filled orbitals. Half-filled and completely filled orbitals. And fourth one, shielding effect or screening effect. Screening effect or shielding effect. These are the four factors which affect ionization enthalpy. Size of atom, nuclear charge, half-filled and completely filled orbitals, and screening effect. Next question, periodic trends in ionization enthalpy. Periodic trends in ionization enthalpy. Along a period, along a period, from left to right, left to right, ionization enthalpy increases. Along a period, from left to right, ionization enthalpy increases. In a group, from top to bottom, ionization enthalpy decreases. In a group from top to bottom, ionization enthalpy decreases. These are the periodic trends in ionization enthalpy. Next question, why ionization enthalpy increases along a period? Increases along a period. This is because, first one, size of atom decreases. Size of atom decreases along a period. Decreases. Second one, nuclear charge increases. Nuclear charge increases. So, ionization enthalpy increases along a period. Next question, why ionization enthalpy decreases in a group? Decreases in a group. This is because, first one, size of atom increases. Size of atom increases in a group. Second one, screening effect decreases. Screening effect increases. Screening effect increases. So, ionization enthalpy decreases in a group. Next question, electronegativity. Electronegativity. Ability of an atom. Ability of an atom to attract bonded pair of electrons or shared pair of electrons. Bonded pair of electrons or shared pair of electrons towards it. It is called electronegativity. Ability of an atom to attract shared pair of electrons or bonded pair of electrons towards it. It is called electronegativity. Highest electronegative element in periodic table is fluorine. Its electronegativity value is 4. Then, Pauling's scale of electronegativity. Pauling's scale of electronegativity. This scale is used for finding out electronegativity. So name a scale which is used for finding out electronegativity. It is Pauling's scale of electronegativity. Pauling's scale of electronegativity. Next question, periodic trends of electronegativity. Periodic trends of electronegativity along a period from left to right, along a period from left to right, electronegativity increases. Electronegativity increases. In a group from top to bottom, electronegativity decreases. In a group from top to bottom, electronegativity decreases. These are the periodic trends of electronegativity. Next question. Electron gain enthalpy. Electron gain enthalpy or electron affinity. Electron affinity. Amount of energy released. Amount of energy released when an electron is added to isolated gaseous atom. Isolated gaseous atom. That is electron gain enthalpy. Amount of energy released when an electron is added to isolated gaseous atom. That is electron gain enthalpy. Next question. Periodic trends in electron gain enthalpy. Periodic trends in electron gain enthalpy. Along a period from left to right, electron gain enthalpy increases. Electron gain enthalpy increases. In a group from top to bottom, electron gain enthalpy decreases. In a group from top to bottom, electron gain enthalpy decreases. These are the periodic trends of electron gain enthalpy. Next question. Second ionization enthalpy is greater than first. Greater than first ionization enthalpy. Why? Second ionization enthalpy is greater than first ionization enthalpy. Why? Answer is during removal of one electron. During removal of one electron, size of atom decreases. Size of atom decreases. When one electron is removed from an atom, size of atom decreases. So, attractive force between nucleus and remaining electrons increases. Remaining electrons increases. Therefore, large amount of energy is required to remove another electron. So, second ionization enthalpy is greater than first ionization enthalpy. These are the 2 points. During removal of one electron, size of atom decreases. So, attractive force between nucleus and remaining electrons increases. So, huge amount of energy is required to remove another electron. Okay. Then next question. Electron gain enthalpy of fluorine is less negative than chlorine. Why? Electron gain enthalpy of fluorine is less negative than that of chlorine. Why? That is, fluorine is small. Fluorine is small. In fluorine, electron repulsion in 2p subshell. Electron repulsion in 2p subshell. Okay. So, incoming electrons are repelled and hence electron gain enthalpy of fluorine is less negative than that of chlorine. Fluorine is small. In fluorine there is electron repulsion. Okay. Then next question, periodic trends of atomic radius. Periodic trends of atomic radius. Atomic radius. Atomic radius increases atomic radius decreases along a period. Atomic radius decreases along a period. Atomic radius decreases along a period. And atomic radius increases in a group. Atomic radius increases in a group. Increases in a group. Next question, what is atomic radius? What is atomic radius? Distance from the nucleus. Distance from the nucleus to outer shell of an atom. It is called atomic radius. Distance from the nucleus. From the nucleus to outer shell of an atom. Outer shell of an atom. It is called atomic radius. It is called atomic radius. Then last question, isoelectronic species. Isoelectronic species. Isoelectronic species. Species with same number of electrons. Same number of electrons. Species with same number of electrons are called isoelectronic species. Example, neon, Na plus, Mg2 plus, Al3 plus, F minus, O2 minus, N3 minus. All these species contain 10 electrons. 10 electrons. So they are examples for isoelectronic species. Species with same number of electrons. Okay.